All right, so in the last meeting, we got to here. We need to move the code, the objects from here, but we started the beginning of whack-a-mole, right? So we rigged it up so when I hit the space bar, it randomly pops up and then goes away, just like you would in a regular game of whack-a-mole, right? So the goal today is to have it where we'll create a game manager that will run a loop, right? Just a continuous loop. And it will randomize where the mole pops up. And then we want to have it so when we click on it, that it goes away. Okay? And then from there, we're going to build it on the device so we can test it on our device. So that's going to be the goal for today. So I just pushed to the GitHub the code that I had done the last meeting. So if you guys want to just pull so you guys can be up to date. Or you guys should be working actually on your own project, right? So we don't have these conflicts. But yeah, if you just follow along, should be okay. If you have any questions, just let me know. So the first thing is we're going to have to write a game manager to control the flow of our game. So we had already created this script, this component called game manager. And the idea here is that the game manager is just going to contain all the possible quote unquote holes that we call. These are basically just the places where the mole can pop up. And then we have a reference to our actual mole. And our mole is just below our actual game scene, just somewhere really, really far, just so we don't see it in the beginning. And the game manager will automatically align it to one of the holes randomly. And then we had created an animation using Unity's animation system under here. So we'll just dock this. So if we click on our mole, we have these two animations here. So we have show, and we can scrub through the timeline here. So you can see it moving, right? So this is the show. So the show is, it's supposed to be below, and it's going to pop up, right? So that's the animation. And then for the hide, it's in the show state, so it's above the ground. And then it's going to just hide, right? So we use basic keyframes, right? So this was all done last week. And then we also had to have a way to invoke these animations. And the way we did that was under the animation, we use this component called animator. So our animator window, we need this in order to control our animation states. And what we did was we just have this default state that we point to it. You can right click on any of these states to make it the default state. So you can say right here, set as layer default state. So if you click on that, it turns orange. So the orange one that you see here becomes the default state. So as soon as the animator wakes up, it's automatically going to transition to this state, and it's going to start here. Now, we want this state that's empty. As you can see here on the motion clip, there's nothing assigned. It's null, so it's not going to do anything. And the reason why we want that is because we are going to control when the animations get called via code. And the way we did that was we had these parameters here. And if we click on the parameter section here, we had show and hide. So if we were to, for example, just run this, right, let's go to the scene view. In code, we can just enable these. And you can see how it's just going to run. And we had disabled the loop on the animation, so it would just stay stuck in the last keyframe. And then in code, we can tell it to hide, and then it just hides. So that's how we have it going between these two animations. So not too complicated. OK. Cool. So So that's an overview of what we did last week. Now let's get to the fun part. So I'm going to just disable the game board, and I'm going to move the mole to a 0, 0 position because I want to see it. Okay. And for reference, I'm just going to create a regular plane here. I'm going to zero this out. And if we go back to our scene view, so when you're working, it's good to have a scene and game view side by side. And let's just look at where our mole's at. And you can see our mole is just right below the surface. So it's hidden, right? And we did this on purpose because we don't want the mole to be seen. And we want the pivot to be at the top of the head, so when it pokes its head and then pokes itself and it hides. Okay. So our mole exists, it's just right underneath the plane. And when you look on top of this, you can see that you can actually see the plane. But if you were to look below, you don't see a plane, right? And that's because this is what's known as just a regular quad. And the way rendering works is the rendering only happens depending on the amount of or where the normals are actually pointing. So this quad only has, see, 1, 2, 3, 4. Split it in half, I guess, because it's the triangles. But it only the only normals it has on these quads are at the corners, and they're only facing up. So when the camera, if you do the dot product, is more than 180 degrees, you don't see anything. If it was a double-faced plane, you would be able to see the top and the bottom, because you would have multiple vertices, some facing up and some facing down, right? So you can use this to your advantage because, depending on what you're trying to do, if you're trying to optimize a scene, sometimes having a double-faced plane is too much. Just have a single-faced plane. For example, if you ever play like a racing game and they have like that billboard, right? And it's like a camera view, and it can see the entire racetrack. Instead of having a double-sided plane when it's rendering two things at the same time on top of each other, one facing this way, one facing that way. But if you can't see the other side, just use a regular quad and only draw on top. Just put the texture on top. That saves you double, another double of your vertices. So in case you were wondering why the plane is disappearing, that's why. Cool. So our goal right now is to have it where the mole pops up and then we tap it and it goes away. All right, so let's try and do that. So some coding will be required. So I like to keep my scripts organized. So under scripts, I like to create folder structures. So it's easier for me to go and look at either modify or just update code, anything. So my mole, I kind of treat this like a movie. So my mole, I think of it as an actor. So I create a folder called actors, right? The whole, keeping things abstract. So my mole is an actor in my game, right? So I'll just create a script called mole, right? Very simple. And I'll just double click this, and it should just open up in Visual Studios. Now, if you downloaded Unity and Visual Studios separate, when it opens, it'll only open the file. It won't open the solution. So the way Visual Studios works is that all your code is inside what's known as a solution. And I'll show you an example of what happens if you don't have them properly linked. So here's going to be an example of how it looks like properly linked. As you can see here in our solution, I see the assembly C#. This is the solution that Unity builds, right? So you can see all the code and stuff like that. And obviously, here's my scripts, and these are the scripts that I was working on the last time. So let's see what happens when it's not linked properly. So for those that downloaded them completely separate, if you go here to, it should be under File, no, Edit, Preferences. Under External Tools, it's possible you might have something else here. Okay. So if you have something like Open by File Extension and you uncheck this, that's usually what it looks like by default, right? And so if we try and open the mole script again, you're going to see that it's going to open up Visual Studios, but it will only have the file. Your solution won't load. And so that can be problematic because you won't get syntax highlighting. Like if you say using, you see right here, it just opened up the file, no solution, right? And so, you know, if I'm trying to do some stuff like maybe pull in like a rigid body, some components that are inside of the namespace for Unity Engine, it won't pop up because they're not linked, right? So you might have that issue. So to fix this, if you do have that issue, go here to Edit Preferences, External Tools. You don't have to use Visual Studios. You can use Notepad++ or even Visual Studio Code. You don't have to use Visual Studios. It's highly recommended, but you don't have to. So mine, I had already found it, right? I had already linked it, but this is how you would link it. You would go to Browse, and you would actually have to find the location of where you put the Visual Studio's IDE. And so that would be under your C drive. Should be under Program Files. Go out to Visual Studios. It should be, okay, so this one's under x86. There you go, Microsoft Visual Studios. You're going to need to go to 2019, or if you have 2018, it will probably say 2018. Go here, go to the, this is Visual Studios Community. And then the part that some people miss is you need to go to under Common 7. It's not intuitive, but you need to go to Common 7, go to IDE, and then look for the executable. And the executable is this dev and env. So it's actually not called Visual Studios. That's the name of the actual executable. So you click on that and you hit open. Okay? Then you'll see that Unity will pick it up. It understands that, hey, this is Visual Studios. But not only that, but you also want to do editor attaching. So you're going to make sure that's checked. Okay? And now, if we open up the script now in Visual Studios, it should link the solution. Okay? Some people might have not downloaded Visual Studios and might have downloaded like MonoDevelop. And if you don't want to use MonoDevelop and you want to switch, that would be the process. Okay? If you have any issues, ask on Discord or just Google it. You'll find it. So here you go. See, now my solution's here. Okay? Now if I say something like rigid body, which is part of the API for Unity, you can see it's giving me IntelliSense. It's helping me trying to find these APIs that are part of the Unity engine. Okay? Cool. So how do we get tapping? And what does it mean to tap? What does it mean to use a mouse click? Right? Because there's two possibilities, right? We want it to work on the desktop so we can play with our mouse and click on the mole. But we also want to deploy this on our device, which would be what? It would be our phones, right? That's kind of our intention here. Or if you have a touch screen device like a computer that's touchscreen, we want it to work there too. So we have all these different types of pointers, right? And by pointers, I don't mean like the C++ pointers. I mean like a pointing device. So Unity has this nice way to abstract all of this. So you don't have to think about, is this a mouse? Is this a finger? Is this touch screen? What is this? We don't have to deal with that. That's the beautiful thing about using an engine like Unity, or a solution kind of like Unity, is that all these things are abstracted, so you don't have to think about this so much. So how do we do that? We need to bring in a component. And so we will say that our mole, because it's going to have pointer interactions, we're going to say at the very top, we're going to say require component type of, and this is a Unity, or this is a C# attribute, and Unity is using this attribute called require component to basically say wherever you have this script, another component must be attached to it, because they're going to go hand in hand. We're creating a dependency here. And it's called event it's the event trigger, but it's not in this namespace, so we need to import it. And that's going to be under Unity Engine .event systems. Okay. Now, what does this component look like now? Right? So let's go back to Unity. As it compiles, let's click back on our mole. Okay. And now let's add the mole script. Now, I'm only going to add the mole script, but because we have that dependency now, Unity will automatically attach all the components that you say are required to have this. So if I type in mole now to add it, it's automatically going to bring in the other components that are required. In this case, we said event trigger. Okay. Now, if you click on add new event type, if we click on this, we have all different types of things that we can do now. We have pointer enter. That's like if you have a mouse and you hover over. You have pointer exit. That means you were on top of the object and then you left. Same like you're in a web browser, you hover over button. It animates and you leave, it animates again. A pointer down, that's when you click down. That's when you're pressing down. Okay? And it's not necessarily a click. It could be anything now, right? It's either a click from the mouse or it's you touching with your finger. Okay? Pointer up, it's when it's released. So you press down on a particular element and then you released. Those events are completely different. And then pointer click is a special event that will wait for a press down and a press up, and it'll tell you it got clicked. Okay? There's also drag. There's scrolling, select, deselect, move, end drag, all kinds of stuff. Submit. Submit would be you clicked on a particular object. It's now under selected, and you hit like the enter key. Right? Okay. So we need to create a method for when the player taps on the actual mole, right? So we say public void. And what should we call the method? Whacked? It's called whack-a-mole, right? So it got whacked. So this mole got whacked, right? So now how do we hook the event trigger to this method that we just created? Well, we want to know what's better, tapping down or actual click? Right, so you probably think we'll do a click, right? Remember, a click requires that you press down and then lift your finger up, right? If it's going really, really fast, like you'll have an instance where you tap on the mole starts to disappear, and it's like it's gone, so you don't actually get that click. So it's always better when you're trying to do things that are speedy. Like, what's another game that does something like this, where you just tap on stuff? It's always best to trigger an event when you touch it first. So we want to add a trigger for pointer down. So when you tap on it, as soon as you press down, something's going to happen. Okay? Now, this new little widget popped up now. So it says pointer down. It says list is empty. So there's nothing here yet. So we're going to click on this plus button. And what we're going to do now is we're just going to grab this script and just place it in here. So in Unity, there's a lot of this drag and drop, which is really nice. Could you do this in code? Yeah. And we're going to do that too. But I want to show you how it looks like from a perspective of you just dragging and dropping. Cool. Now, what is this going to do? So Unity is going to use reflection to figure out all the public methods. That's why we had to make that method public. And it's going to give you a gigantic list of all the methods that it sees that are public, that it has access to, and then you can link it. So if I click here where it says no function, it's going to first give you a list of all the components that you have access to. There's our mole. And it's going to give you a list of all the public methods that it has access to. And look, there's our whacked. So let's click on that. Cool. Nice. That's it. Now it's linked. So when you tap on it or click on it, just by pushing down on it, it's going to call that method. Isn't that pretty cool? I think that's pretty cool. So for debugging purposes, let's just log. So debug.log got whacked. Just like that. Got whacked. Okay.
So I guess the event trigger already include like the observer and the observable?
Yeah, that's basically what's happening. All of these things are events that we can subscribe and listen to. That's basically what's happening. So behind the scenes, that's what it is. This is a what's known as a event a subscriber subscriber notification pattern. It's basically like the observer, except this is based off events and not necessarily data changes. Yeah, I guess you can think of it like that. Because this has nothing to do with data being changed. These are just things that are happening, right?
Event-driven?
Event-driven. There you go. There you go. Event-driven.
That's how I ace 131, guys.
All right. So now let's get our plane and then disable it, and let's hit play, and then let's click on our little mole and see what happens. So we're clicking, but nothing's happening. Okay. Now why is that? So in order for the event trigger to work correctly, there is one more thing we need. The event trigger is technically supposed to be used for the Unity UI system, but we can extend it. So the way it works is when you click or touch on the screen, what Unity is going to do is it's going to, wherever you touched or clicked or whatever on the screen, it's going to raycast into the world. Straight from that position, wherever you were, it's going to just raycast into the world and see what it hits. Okay. Right now, it's not doing that, so we need to add a raycaster. So let's go to the main camera and go to a physics raycaster. Okay. Now we should just be able to hit play, and then if we just click on it, oh, is it this one? No, it's not this one. I lied. No, not that either. Oh, I know why. Because we need an event system. Now we can do it. And then we need a raycaster. There we go. Okay. So prerequisites. You need an event system. And this is the way that Unity is going to basically check. Bless you. It's going to check for any events that are happening, any clicking. So that's what we need. We need this event system, right? And then there's a standalone input module. It's going to take all the inputs, and it's trying to abstract this away from you. And it's going to allow it to, what it's supposed to do, is it's supposed to work with the UI system. That's why you'll find this under Create, UI, Event System. But we're not using UI, right? We're kind of doing this in a different way. We want the event trigger to work on a 3D object. So in order for that to work, we need a raycaster. And use the physics raycaster. And this will shoot out. And the way this works is, here's our camera. Again, if you tap in, wherever you can see here, this is the full strom. It's going to shoot out a ray. Now, how does it know when to stop? And the reason why it's called a physics raycaster is because on our graphic here, our mole, we have this collider, and that's how it knows that it hit something. If we don't have that, it's just going to pass right through. It won't raycast onto meshes. right? Because that's too expensive. It would have to raycast a bunch of different things. You have a bunch of little particles. It'll have to raycast through all those particles. Bless you. So we can filter this by adding a collider. Okay. So we have an event system. On our main camera, we added the physics raycaster. Okay, here's an event mask. Basically, it's going to hit anything on this layer. So we can further optimize by removing layers to only search for or only activate onto layers that we tell it to, right? Right now it's on everything. That's not good, but just for now, whatever. Okay. So now when we hit play and we click on our little capsule, it's going to say got whacked, and we just keep doing it, right? Now, we want to do something, right? So the point is, when it gets whacked, what do we want to do? We want it to go down, right? So because we're going to require that we have an animation attached to this, a nice way to ensure that you're not going to get a null ref is to say under here, the required component, we're going to say type of animator. Okay. So let me zoom in here. Is that better? Is that better? Can you guys see me? Is that better? Okay. I don't want you guys squinting. Cool. So let's do this the naive way. And when it gets whacked, we're going to still log got whacked. But now we need to get a reference to this guy. Remember, this is a component, right? How do we get a reference to it? Well, the component we want is the animator, right? So it's called animator. We'll call it anim for short. That's going to be our variable. We need to grab it. Now, how do we grab this? Well, because we're deriving from mono behavior, there is a special function that we can use. It's called getComponent. Right? It's pretty self-explanatory. We're trying to get a specific component. And it's a generic type. Right? So it has it's a, every time you see a T or an E kind of thing, it's a generic. The restriction is that the component must derive from mono behavior, or else you can't attach to a game object. It doesn't know, right? But luckily, the animator does derive from mono behavior. And that's it. We invoke it like that. So this ensures that Unity is able to grab the component off of this game object. Because remember, the Unity engine is a component oriented. So I don't know if I explained this the last time, but a game object is just a container. Okay, it's really nothing special. It's just a container, and it contains other components. So Unity uses this because now you can have a game object, right? That's a container. And you can contain many components, right? And what's cool is that those components will get updated via the container. The container will tell each component when to update. So this is a nice way to basically use components so you can have a separation of concerns. Each component can do a specific job. And when you pack them all together, right, in your little container, you can use it to solve a specific problem. In this case, I want to create a mole, right? The animator component doesn't know it's on a mole, nor should it matter, right? The event trigger doesn't know that it's next to an animator component or a mole, nor should it matter. But the mole is going to work with all of them, and notice how we're able to sync them all together very nicely, right? Cool. Now, we want to say anim dot set trigger, because that's what we created in the last meeting, these triggers. Now, which one do we want to invoke? Show or hide? Hide, right? Say hide. Okay. Let's go back here. All right. Now let's see what happens. Let's hit run. And then we're going to click on it. Right? So it is moving. Now why is it doing that weird jumpy thingy? That's because it's already in the hide state. So if we have the mole selected, we can look at the animator. It's already in the hide state. And it's trying to transition to the hide state. Every time I click. You see how you see this little blue thing right here? This is a transition. It's transitioning into itself. That's why you get that little weird jumpy thingy. But if I activate the show, it's up here, assuming the game flow is the way it's supposed to, it shows up, and then we click on it, it does what we think it's supposed to do, right? Cool, right? So that's it. That was just tapping, right? Anybody questions about that? Not bad, right? So now we have a way to tap. Okay. So let's bring our plane back. Okay. Let's put our mole at, I believe it's at 1 or 0. I think it's at 0 for the show. Yes, we move it to 0. So let's force our mole to, don't want to preview, to start at 0. Okay. You can hit save here, hit play. So let's assume we're in this scenario where the mole is popping up. And when we tap on it, it goes away. And if I'm tapping again, I keep tapping on the mole, but nothing's happening. You see, before I kept jittering, right? Because we were tapping on it. That's because the plane has a collider. And so what's going to happen is the physics raycaster is going to hit it's going to only select the first thing it touches. And what did it touch? It touched the plane, because the plane has it must have a collider, and it's called a mesh collider. And if we look at it here in the scene view, you can't see it, right? Because here on our mole, it turns like you have this green thing. On mesh colliders, you can't actually see it unless we turn on convex. That's something different. And it creates that, though that's not the true representation of the actual collider. Right? Only when it becomes convex. And the reason why it's convex is because it's going to try and close the loops. See, here, we already know that we only have a vertex here, here, and here, and here. Because if I go underneath, we can see right through. So this only has, if you think about it, a collider just on the top, on the surface. So it's not wrapped. Versus a cube, it's wrapped. All the points can eventually loop back, so it's circular. But not this. That's why I can tap on here and nothing happens. Cool, right? So the next thing is, let's make sure this is working on our device. So let's build to our phone. Okay. So how do we do this? So if you have an Android phone, right, you should have had Android Studio already downloaded, right? You guys have Android Studio? No? Okay, well. The only reason why you need Android Studio is so you can work with the SDK manager. And I just realized I'm out of USB ports. Dang. No, because if I remove my mic, yeah. So how do I do this? Oh, I know. I'll just do it the super long way. I'm gonna throw it up on Google Drive and then download it here. All right. So how do we do this then? How do we make an APK? Well, that's the beautiful thing about Unity. You literally just go to File, Build Settings. Okay. Whoops. Make sure you're on Android. Okay. we're going to go to the player settings. So it says here, Unity has detected Android SDK at that location. Do you want to use this SDK directory? This is a fresh install of Windows with a fresh install of every software, including Unity and Android. And I did this on purpose. So when we see errors like this, you guys don't freak out. I have already downloaded Android Studio. So it's going to place the SDK in a particular location. Unity will try and look for the SDK. And the way it's able to find that is because Android Studio will create an environment variable, and Unity is going to try and see if Android Home exists. In this case, it did. And so we just say, yeah, go for it. In the case that it doesn't do that for some reason, if you go to Edit, Preferences, under External Tools, you have these little fields where you can try and locate your SDK. So in the case that you have it in a D drive or F drive or somewhere else, you can click on Browse and just start looking for it wherever it is that you placed it. Okay? Cool. All right. So I have already set up the player settings. So one thing that's required is that you have to change the company name, because by default it will say default company. You have to change that. Give it a product name, call it whatever. And the other important part is under other settings, you have to change the package name. It's going to say com.company with a capital C dot, I forget what. But if you try and build without changing the package name, it will give you an error. It'll say you can't. You have to change it, and you have to change it. I call this Whatamole. That's supposed to be Whack-a-Mole. Whack-a-Mole. There you go. Cool. Now, if you wanted to deploy to Google Play Store, the requirement now is that the minimum API has to be API 9, which is Pi. Okay. Now, if you're running on an older Android device that doesn't support 9 for whatever reason, for example, I have my Nexus 5X. The highest this one went is 8.1. Google dropped support for this. So if I wanted to test with an app that's running Android 9, I can't, right? So one thing you can do is download an SDK that's much lower, that covers all the devices that you have for testing. But I will say that's incredibly dangerous, because if you want to deploy to the Google Play Store, you're going to need to have access to a device that is running the requirements that Google has. For example, running Android 9. Okay? So I'm just going to use NuGet. Okay? And that's about it. So I'm just going to go to File, Build Settings, and I'm going to just say Build. Okay? Hit Build. Make sure you have the scene. Right now we're in the scene called main. This is right here, main.unity. Make sure that's in your build settings. Okay? Let me just delete these. One way you can do it is the current scene that you're actually in, you can actually just say add open scenes. And that's one way. The other way is if you have the scene here, again, the beautiful thing about Unity is you just drag it into here and then you're good. Right? That's it. Now we're going to hit build. When I hit build, it's going to ask me where would you like to place the APK. So I'm going to hit build. Now it's kind of like standard that in your project folder you have a folder called builds. So I'm going to have one called builds, right? And inside here I'm going to separate my build types. So here I'm going to have one called Android. So all my Android builds will be in the Android folder. If I'm going to build to Windows, put it in there. If I'm going to build to Xbox, put it there. So here I'm on Android. File name, Whack-a-Mole. Save. Okay. And now this is going to build a Gradle project and everything. Okay. So select Android NDK. Ooh, I don't have the Android NDK. So we're going to say cancel. So the reason why it's going to try and locate the NDK is that it's possible that this thing is on, Yes, it's using IL2CPP. So if you have that issue where it wants the NDK, switch it to mono. Okay, switch it to mono. And then just select x86 or ARM7. We'll just stick with x86. All right. Clear that, hit build. Same thing, hit save, and it should work. Okay, there it goes. Now it's building. Now, if it's your first time building an Android APK, it's going to have to build out the shaders. A lot of these shaders are called compute shaders. So instead of having the actual mobile device compute them, it'll compute them on your computer, so it doesn't have to do it on the phone. So, you know, yeah. Because it already knows that the Android environment's going to be, you know, oh, it's going to use OpenGL or whatever. So it'll try and do it on your computer. So sometimes you'll have these, it'll have like shader, whatever of 1,000 or something like that. So it has to go through all these processing, and then after that, you should be good. Now, mine's going to run slower because I'm recording. So yeah, we just wait. So there's like a joke, right, of like two programmers. They're like on these chairs and they're like playing around the office with like swords, and then like the boss comes in and says, "Why aren't you guys working?" And they're like, "We're compiling." He's like, "Okay," and just leaves. Because most of the time you're probably gonna just stand here, just, you know, compiling. So as you can see here, look, we're doing all these shaders. So now we just wait. The bummer is like you have a project that's like 20 gigs. That's going to take you probably an hour or more. And then it almost gets to the end, and then it says failed. Right? So that's not fun. I've had projects like that where you're there for like 30, 40 minutes, and then at the very end it says failed, and it's because either OpenJDK, no. Something simple, like, you know, you're missing something, you misspelled something. Bummer. All right. So while that's happening, I got to sign into my Google Drive. So I'm going to throw this up on my Google Drive. No, it's just, I don't know. I tried to put zeros and they were taken. I tried 1020 and it's like, yeah, it's available. Okay, cool. Moving on. Cool. So I'm just going to throw this up on the SoDA drive under miscellaneous. Okay, and then just wait for this thing to run. Did you guys get a build? No? Nobody? You guys there yet? Does anybody have an Android device, an Android Studio installed? No?
Everybody?
All right. All right.
I'm ahead, man. Let's go.
I'm going to make the link to the actual APK public. So if you don't have, or well, you don't, oh yeah, if you don't have Android Studio, we can just, I'll just place this guy over here and let this upload. Get shareable link, make it public, copy this, open up the Discord, and then we're going to go to SoDA under General. There you go. So now I'm just going to go on my phone here. A super long-winded way.
So if you were to just plug in a phone and
It'll build straight to it.
oh, it'll just build
Straight to it. I just don't have any USB ports because I'm running Windows on an external SSD that's using a USB port. I'm using a USB mic. That's using a USB port, and I have a Mac, so I only have 2 USBs. And I forgot that I was going to do this, and I have a USB hub, and I wasn't thinking, so my bad.
Do you have Drive on your phone?
What?
Do you have Google Drive on your phone? You can download it.
Well, I made the link public, so I just have to click on it, right? So for, obviously you guys can't see because I'm recording, but for everybody else, if you're on Android, you can actually install an APK, I don't know if you know, off the internet. You don't need to go through the Google Play Store. Now, if you do this, though, you have to go to settings. I forget where. It's different depending on what kind of manufacturer you have for your Android. You have to allow external or unsigned APKs. You can Google it and figure it out. But anyways, what's that? No, that's if you want to sideload from the computer. Here we're trying to install an APK from the interwebs. Because here I'm going to hit download. And as soon as it's done downloading, it'll automatically detect that, hey, this is an APK. Would you like to install it? And if it might fail the first time because it's going to say it doesn't have proper permissions or something like that. So that's definitely possible. Okay, so we'll just see how long this takes. Okay, so Android has a app called Files. So you go there. You should go under Downloads. Drive, developers. I don't know. I just went to the Google Drive. That was faster. So I got this warning saying your phone and personal data are more vulnerable to attack by unknown apps. By installing this app, you agree you are responsible for any damage to your phone or loss of data that may result from its use. I'm just going to hit continue. And they say, do you want to install this application?
I'm sure it's not a virus.
I'm sure.
Put a virus on your phone now.
Possibly, maybe. So it says app. It says, so right now it says app not installed. So
it's probably because your APK.
Hmm.
APK version you got was needed.
No, should be okay.
No, some when I try to like get APK from older version of Android, there's a
No? All right. Well, this one's running 9. So let's make a... it's possible that it was x86. I probably should have picked ARM7. Let's go with that. Yeah. But anyways, this will be the steps that you will have to take in order to make a build. And as you can see, it's actually pretty simple. It's not that bad. It'll be faster on your computer when you're not screen recording. So we should be good. All right. So I'm gonna end the this session because we actually have a guest speaker who's gonna phone in via Google Hangouts. So. Let's see, inbox. Cool. All right. Say hello. Hey, Angela, can you hear me?
Hello?
What's up, dude? All right.
I can't see you at all. Do you have a camera?
Oh, yeah, I have the camera disabled here. Let me just, pow. There you go. And then let me just disable OBS, and it should be good.